Chapter 13, question 8 says, asks you to identify the chiral carbon in each of the following naturally occurring compounds. And remember that the term chiral means handed. So a carbon is chiral if it has 4 different sides. Now in this case, that's going to mean that it is bonded to 4 different groups. In other words, bonded to 4 different groups. And you're looking at the whole group all together. So bonded to 4 different groups. The significance of that is that things that have 4 different sides come in 2 versions, a left-hand version and a right-hand version, just like your hands, which have 4 different sides, a back, a palm, a thumb, and a pinky side. Come in a left-hand version and a right-hand version, and the right-hand version doesn't fit in the same pockets as the left-hand version does. So a right-handed molecule won't fit into a left-handed pocket, and vice versa, just like a right hand won't fit into a left-handed glove. So whether a molecule communicates the message that it's intended to, either as a hormone or a neurotransmitter or a drug, depends on whether the chiral carbons are the right type of handedness. Okay, so that's the significance of this, the importance of this. Now, so let's go through these molecules. We're going to go 1 carbon at a time and look for carbons that are chiral, that are bonded to 4 different things. Now, in this first molecule, amphetamine, which is a stimulant, and they use it to treat ADHD, we'll only look at the carbons whose C's are drawn, so don't worry about this ring. If we were to go through that, you would see that it is not, that each of those carbons are not chiral, that they're actually only bonded to 2 different things. But let's just focus on the carbons that are drawn. So first this one on the left. Let's see if that's chiral. Well, one thing it's bonded to are the hydrogens. Which is a colorful one, hydrogens. So that's one thing. The second thing it's bonded to is this weird group. And the third thing it's bonded to is this ring on the side. Let me actually use this ring on the side. But that's only 3 different things. You only see 3 different colors there. In order to be chiral, you have to be bonded to 4 different things. And so this is not chiral. That particular carbon is not chiral. Okay, let's see about this carbon. On the left, it has this group that it's bonded to. On the right, it has this group, which is different. On the top, it has yet another group that's different, a methyl group. And last but not least, it's also bonded to a hydrogen. A hydrogen. So there you have 4 different things that carbon is bonded to. So that carbon is a chiral carbon. That comes in 2 versions, a left and right-handed version. This is chiral. Okay, well there's one other carbon we need to check out. It's this one right here. We can see that's bonded to hydrogens, and it's also bonded to this gigantic big group. But that's only 2 different things, not 4, and so that carbon is not chiral. Now for this course, Principles of Chemistry, you really only need to worry about carbon, but theoretically you could have elements that are chiral. They just need to be bonded to 4 different things. If you really wanted to check, you could see that that nitrogen here is not chiral, because it has only 2 different groups that it's bonded to, this big weird group on the left and then the hydrogens. But for our class, you need to just look at the carbons. So we only have that 1 chiral carbon there. Now let's look at norepinephrine, which is a hormone. And don't worry about the ring again, so we're not going to worry about that. Only look at the carbons that are drawn in. This carbon right here, let's think about that. Well, there's an OH on top, that's one thing. There is this whole group on the left, that's a separate thing. There's the hydrogen, which is not part of that left group. Hydrogen, you would draw that going down if you drew the bond for that. And then there is the ring. So that's 4 different things. You see 4 different colors there. That carbon is bonded to 4 different things, and therefore it is a chiral carbon. This carbon comes in 2 different versions, a left-hand version and a right-hand version, and they would affect a creature, be it animal, human, plant, differently. Each version would, whether that carbon is left or right-handed. So that is a chiral carbon. Let's think about this next one, this one right here. That's bonded to hydrogens. Separately from that, you can see the bond to this nitrogen group, so that's 2 things. And then you can see a bond to this gigantic group on the left. This whole thing. But that is only 3 different groups that carbon is bonded to. You only see 3 colors there. So that is not chiral. In order to be chiral, an atom has to be bonded to 4 different groups. And that would be it for this one, just that one carbon there.